Right now, without feeling it, without knowing it, you are moving at 230 kilometers per second. Not in a plane, not in a rocket, just sitting there, reading this, existing, hurtling through space at 230 kilometers per second, around something 26,000 light years away that we couldn't even photograph until 2022. Something that has been pulling you and every human who ever lived in a silent circle for billions of years. And for most of human history, we had no idea it was there. This is the story of Sagittarius A*, the black hole at the center of our galaxy, the dark heart of the Milky Way, and the invisible thing you've been orbiting your entire life. For thousands of years, people looked at the Milky Way as a band of light stretched across the sky, beautiful, diffuse, mysterious. By the early 1900s, we understood what it was, a spiral galaxy, and we were off to one side, 2/3 of the way out from the center. We assumed there was a center, some dense region where starlight pooled. We thought it was just more stars, closer together, nothing special. The problem was that between us and the galactic center, enormous clouds of gas and dust block all visible light completely. When you point a normal telescope toward the center of our galaxy, you see nothing, absolute darkness. For centuries, the core of our own home was hidden from us. Then, in the 1970s, radio telescopes changed everything. Radio waves pass through dust, and when astronomers aimed radio telescopes at the galactic center, they found something that didn't fit. A powerful, compact radio source, bright, concentrated, completely stationary. Too bright to be starlight, too small to be a star cluster, too compact to be gas. They named it Sagittarius A*, after the constellation where it appeared in our sky. Something massive was sitting there, something invisible, pulling everything toward it. But here's the problem with black holes. You can't see them. You can only see what they do to everything around them. So in the 1990s, two teams of astronomers began one of the most patient experiments in the history of science. Two observatories, one in Hawaii, one in Chile. Both aimed infrared cameras at the same patch of sky, the galactic center. Infrared light passes through dust, just like radio waves, and they started watching. Not hundreds of stars, just a few dozen, year after year, image after image, watching individual stars near Sagittarius A* move. And those stars were not moving slowly. They were whipping around something invisible, like planets around a sun, but far more extreme. Tight orbits, elliptical, violent. One star became the key, a blue-white star, unremarkable except for where it was and how it moved. The teams called it S2. S2 orbits Sagittarius A*, 16 years. To understand why that's extraordinary, our Sun takes 230 million years to complete one orbit of the galaxy. S2 does it in 16. At its closest point to the black hole, S2 gets within 17 light hours of Sagittarius A*. For comparison, Neptune is only 4 light hours from our Sun. S2 gets 4 times closer than that to a supermassive black hole. And at that distance, it accelerates to 3% the speed of light, fast enough to cross from Earth to the Moon in under a minute. Scientists followed S2 for decades. They watched it complete one full 16-year orbit from close pass to close pass, frame by frame, year by year. They could see it accelerate as it approached the black hole. They could see it decelerate as it moved away. The path was perfect, exactly what you'd expect from an object orbiting a massive point source. Then they did the math. To make a star move that fast in an orbit that tight, something extraordinarily massive had to be at the center, concentrated in a space smaller than Mercury's orbit around the Sun. The answer, roughly 4 million solar masses. No star cluster could be that dense without collapsing. No gas cloud could hold that much mass in that little space. Only one thing fit. By 2002, the case was closed. Sagittarius A** wasn't just a radio source, it was a black hole. Our black hole. 4 million times the mass of our sun, sitting 26,000 light-years away, and we'd been circling it the entire time. For decades, we knew Sagittarius A* was there. We could measure its mass, track stars orbiting it, map its gravity, but we'd never seen it. In 2019, the Event Horizon Telescope, a planet-sized network of radio dishes working together, released the first-ever image of a black hole, M87A*, at the center of a galaxy 55 million light-years away. A glowing ring, a dark shadow, proof of concept. Then, in May 2022, they released a second image, Sagittarius A*, our black hole. It took longer to photograph than M87*, because Sagittarius A* flickers. Gas swirls around it on timescales of minutes. Brightness shifts constantly. The team described it like trying to photograph a child that won't sit still, except the child is also 26,000 light-years away, and you're using a telescope the size of the entire planet Earth. Telescopes in Chile, Hawaii, Arizona, Mexico, Spain, the South Pole, all synchronized, all working as one instrument, combining signals, compensating for Earth's rotation, building an image, pixel by pixel. And then they had it. A bright ring of hot gas, its light bent into a circle by gravity, and in the center, a shadow, a dark silhouette where light is captured and never returns. For the first time in human history, we saw the face of the thing we'd been orbiting our entire lives. Let's talk about what 4 million solar masses actually means, because numbers at this scale are designed to break your intuition. So we're going to build up to it carefully. Start with our sun. If you compressed the sun, a 1.4 million kilometer wide ball of nuclear fusion, into a black hole, its event horizon would be about 6 kilometers across, smaller than a city. Now imagine doing that 4 million times and crushing all of it into a single point. That's Sagittarius A*. The event horizon, the point of no return, is about 24 million kilometers across, roughly 17 suns laid side by side. Light, traveling at 300,000 kilometers per second, takes about 80 seconds to cross it, a minute and 20. Now, what is the event horizon exactly? This confused a lot of people in other videos, so let's be clear. The event horizon is not a surface, it's not a wall, it's not made of anything. It's a line in space, a boundary where the escape velocity, the speed you'd need to escape the gravity, exceeds the speed of light. And since nothing travels faster than light, once you cross it, there is no escape. Not because something is blocking you, but because every direction, including the direction called away, leads further in. Inside the event horizon, away stops being a direction. The geometry of space itself changes. That's not poetry. That's what Einstein's equations actually predict. And Sagittarius A* is the closest place in the universe where that's happening. Now for the mass comparison that puts it in perspective. Sagittarius A*, 4 million solar masses. M87A*, the black hole photographed in 2019, 6.5 billion solar masses. TON 618, one of the largest ever discovered, 66 billion solar masses. TON 618 is 16,000 times more massive than our black hole. By comparison, Sagittarius A* is tiny, but tiny is relative. 4 million suns, 1.3 trillion Earths compressed into infinite density, and it's the closest supermassive black hole to Earth. This is the neighborhood version of the most extreme thing the universe produces. Here's something that should genuinely disturb you. Sagittarius A asterisk is 26,000 light-years away. That means the light we use to observe it left 26,000 years ago. 26,000 years ago, humans were living through the last ice age. Small bands, firelight, stone tools. The first cities were still 10,000 years in the future. Writing didn't exist. Agriculture hadn't begun. The photograph of Sagittarius A asterisk released in 2022, that's what it looked like 26,000 years ago. The orbit of S2 that we've been tracking since the 1990s, we're watching events that happened 26,000 years before we saw them. Everything we know about our black hole, every measurement, every image, is ancient history. And there's no way around it. Light has a speed limit. Information has a speed limit. We are separated from Sagittarius A star not just by distance, but by time itself. What is Sagittarius A star doing right now, in this exact moment? We can't know. Not for another 26,000 years. All we have is the past. Always the past. Let's go back to where we started. You, moving at 230 kilometers per second. That's fast enough to circle the entire Earth in about 3 minutes. But Sagittarius A star is so far away that one complete orbit takes about 230 million years. The last time our solar system was in this exact position in its orbit, dinosaurs hadn't appeared yet. The next time we come back to this spot, 230 million years from now, Earth may be unrecognizable or gone, and Sagittarius A star will still be there, still pulling, still patient. Stars closer to Sagittarius A star orbit faster. S2, 16 years. S62, another tracked star, just 9.9 years, screaming around the black hole at nearly 10% the speed of light. Farther out, stars take thousands of years per orbit. At the edges of the galaxy, hundreds of millions of years. Some stars have been circling Sagittarius A star for billions of years. They'll keep circling for billions more. Generations of stars, born, living, dying, all held in orbit by the same invisible anchor. Sagittarius A star doesn't hurry, it doesn't rest, it doesn't notice. Every star near the core bends to it. Every orbit, every trajectory, every motion, shaped by gravity from something that can't even be seen. Right now, somewhere in the direction of the constellation Sagittarius, there is a black hole. You can't see it with your eyes. You can't point to it in the sky. It's not the most massive black hole in the universe, not the farthest, not the brightest, but it's ours, the center of home. You've been orbiting it your entire life. So have your parents. So has every generation before you. So has every star you've ever seen in the sky. All of it held by something we couldn't even photograph until 2022. Something we can only ever see as it was, never as it is. The invisible thing at the center of everything. Patient, quiet, inescapable. You're circling it right now.